Show, by counterexample, that the statement cos 2 theta is equivalent to 2 cos squared theta minus sine squared theta is false. Find all the values theta in the range of theta between 0 and 360, satisfying 3 tan squared theta equals 7 plus sec theta. So I've summarized the question here. Let's have a look at it then. We just need one counterexample, one value of theta where this is not going to be true. It's easy to put theta equals 0 in, so let's try that then, shall we? That's the first port of call. So cos of 2 times 0 is cos 0 will equal 2 cosine squared of 0 minus sine of 0. And this is 0 radians or degrees, isn't it? Here we can put in. Cos of 0 is 1. Cos of 0 here is 1. So 2 times 1 is 2. Sine of 0 is 0. So 2 minus 0 is 2. So this is not true, which is not correct. So it's false. Right, that's part A completed then. Part B. Let's have a look at this one then. Now, sine squared plus cos squared is 1, so that tells us if we divide by cos squared that tan squared theta plus 1 is equal to sec squared theta. Sine squared plus cos squared equals 1. Divide by cos squared all the way through and we get this. So that's the trig identity that we need then when we're looking at part B. So here tan squared, if we replace it by 1 plus sec squared, we'll get a quadratic in sec, which we should be able to factorize, hopefully. So here 3 of tan squared plus 1 is sec squared, so it will be sec squared theta minus 1 is equivalent to tan squared, is 7 plus sec theta. So let's turn our attention to this part of the problem now then, and solve this. So here we've got 3 sec squared theta, expand the bracket, minus 3 equals 7 plus sec theta. Move everything over to the left to be with the 3 sec squared theta. So it's minus sec theta then. Minus 7, there's already a minus 3 then, that makes minus 10. Now we can factorize. We've got no choice about the 3 sec theta. It has to be 3 sec theta and sec theta. Now if we do 5 2's, 2 and a 5, the difference will be of that product, so will be minus 1, won't it? Provided we put that to be the minus and this to be the plus. So that tells us then that sec theta is equal to minus 5/3, or sec theta equals 2. Now sec is 1 over cosine, so let's invert the fraction. Here on the left is cos theta, here is minus 3/5 if we invert it, and here cos theta, if we invert the fraction on the other side as well, is equal to 1/2. So these are the two problems then. Let's solve them. Draw a circle, right cast. We're solving between 0 and 360 degrees. Cosine is negative, it's positive here and here, it's negative there and there. Draw 2 lines, mark off alpha to the horizontal and simply write cosine alpha, and drop the negative if there is one to drop. So alpha then, shift cos of 3/5 or shift cos 0.6. We need to be in degrees mode. So let's go into degrees mode, which is number 3. So shift cos of 3/5, which is 0.6. Easy to put it in as a decimal. 53.1 degrees. So there's alpha here. In here, so we can read off theta between 0 and 360, go around to there, 180, back 53.1, so that's 126.9 degrees, and then the other solution is right round to here, isn't it, 180 plus 53, which is 233.1 degrees. So there's our two solutions from that problem. So let's have a look at the next problem now. So draw a circle, right cast again, cos is positive here and here, draw 2 lines, mark off alpha, the associated acute angle, and simply write cosine alpha is equal to 1/2. Cos of 60 is 1/2, isn't it? So alpha will be 60 degrees, won't it? So Theta is also equal to then, if we go around for the first solution, it's 60 degrees, because alpha was 60 degrees, and the other solution is right around to here, isn't it? Which is around 360 back 60, which is 300 degrees. So there's our 4 possible values of theta. We could check them if we wanted, when we were double checking the problem to see if we got it correct.